That's complex numbers. Up until this point, when I ask you to solve something like, if I ever ask you to solve x squared minus 4 equals 0, how would you solve that? Okay, so you get x squared equals 4, and then what do you get? Plus or minus 2. Very good. Okay. Now, what if I had given you x squared plus 4 equals 0? What would you do? Yeah, so it becomes? Yes. You what? Yeah, so you square root and you get plus or minus the square root of negative 4. Okay? But up until this point, in the real number system, there's no solution to this. But there's a different kind of number system called the complex number system, where there is an answer to this. The answer is plus or minus 2i. Okay? So I is the imaginary number. I is equal to the square root of negative 1. So then I squared is equal to square root of negative 1 squared, which is, what's the square root of negative 1 squared? Yes. No. If you square a square root, it gets rid of this. If you square a square root, it gets rid of the square root. So it's negative 1. I cubed is equal to I times I squared. Do we agree? So this, what's I squared again? So then what's I times negative 1? Yes. And I fourth is the same as saying I squared squared. But what's I squared? What is I squared? Just I squared. And so negative 1 squared is? Careful. 1. You can write this conveniently in a chart. I squared, I cubed, I fourth, where I is the square root of negative 1. This is negative 1. This is negative I. And this is, I is just equal to I, sorry. And I fourth is 1. And you can write any expression that has an I cubed, I fourth, I tenth. You can write it always in terms of just I, or the real part, which is just the real part of a complex number is the one without an I. So if I gave you 2 plus 3i, this is the real part, this is the complex part. Okay? So why do we do this? Complex numbers have uses in electrical engineering, in physics, and yeah, we use i's in different real-life scenarios. But it allows us to have a solution to this problem. Okay? So let's work on converting complex numbers. So converting to complex. So say that I had square root. Write this. Well, this, from radicals, you'll remember that this can be written as square root of negative 1. You can take negative 1. The square root of 4 and the square root of 3, because the radicands, when you multiply them, they all make negative 12. Why do we pull out 4? Because it is a perfect square that can be square rooted to a whole number. So the square root of negative 1 is I. The square root of 4 is 2. The square root of root 3 you can't take, so you get the answer 2i root 3. That's the answer to this in complex. That's how you change that to a complex number. Okay? if I wanted to convert, say, let's say 5 square root of negative 27. Okay? How can you rewrite this as a product of radicands? Go ahead. You can use your calculator. Take your time. Not cube root. Oh, yeah, you're only doing square roots. So you can only pull out perfect squares. Name your perfect squares. 4, 9. What's the next one? Just name me your perfect squares. 4, 9, 16. Right. And you can keep on going, right? So what one comes out of here? 9. Yeah. So square root of negative 1, square root of 9, square root of? Yes. Because 9 times 3 makes 27. So you always pull out the I part, and then you break down the radical like you normally would. Okay? So you end up getting 5I times 3 root 3. What's your final answer? Yeah, good. Okay? All right. Let's talk about working with complex numbers. Working with complex numbers. That would be something like taking I and multiplying it by 2 plus 3I. You can simplify that expression. Yeah. Oh, okay. Sweet. Thank you. Good job. No? There will be a whole bunch tomorrow because there's a whole bunch of school stuff to do tomorrow, but yeah. Thank you. Go ahead. So, no, you don't. You want to leave them as i's. So the first thing we did was converting complex numbers because you want them as i's. You don't want them as square root of negative ones. But I'm saying like you can distribute. You can write everything in terms of just I or no I. So I times 2 is 2I, and then good, 3I squared. But like I said, everything can be written as I or no I squared, remember from the chart, I'll write it again. I is equal to I squared equals negative 1, I cubed equals negative I, and I fourth equals 1. So I squared is what? Yes, so then you can put that in to get that. And so you get minus 3. We usually write the real part first and the complex number afterwards. That's called A plus BI form. Okay. What about this? Negative 3I cubed. Slow it down a bit for me. Do you cube the negative here? Like, let's apply the cube. Okay, so you get negative what? Good. 3 to the power of 3 is 27. Let's just leave it like that. Then, once you're done expanding and simplifying, then you can go put in. What do we put in for I cubed? Yes. So you get? Good. Got it? Okay. What about something like this? 2 plus I minus, let's go 2 plus I, 3 minus I to the 4. Go. Good? Good. What's this? And I5. So what do we do with I5? The way I5 works is you start here. You go 1, 2, 3, 4, 5. Yeah. 6 minus 2 is? 3I minus I is? Yes. Okay. There's 2 more things we got to look at. Bye. See you. So, remember that from radicals, if you get something like root 2 plus if I got root 2 plus 3 over 3 root 5. In radicals, there's a rule. You are not allowed to leave roots in the denominator. Okay? You'd multiply both the top and the bottom by root 5. You don't take, when it's a monomial in the denominator, you do not take the 3 with you. Okay? That's similar with this. 2 plus 3, if I was to say 2I plus 3 over 3I, just making that up there, you are not allowed to leave I in the denominator. So you multiply by I over I. It's okay in math to multiply by 1. So if we do the same thing to the top as we do to the bottom, then it's okay. So this has nothing to do with this. I was just reminding you of radicals. So then you expand. So 2I plus 3 times I is, you can put brackets around this, and you get? Good. And now on the bottom you get 3I squared. Now we're going to get rid of i's, because what's I squared? Right. So you get negative 3 in the denominator. I'll write it in. 3 times negative 1. 2 times negative 1 plus 3, I. You can put the negative 1 in for I. Right? So you get negative 2 plus 3I over negative 3. The better way to write this, though, is to write each part over top of that negative 3 so that you get negative 2 over negative 3 plus 3I over negative 3 so that you can get it into A plus BI form, separating the real part from the complex part. Okay? Negative 2 over negative 3 reduces to? And 3I over negative 3 reduces to? Yes. That's the answer to this. Okay? There's one more case, and that's when there's a binomial denominator. The first module is all on complex numbers. So here, what if I have a binomial denominator, like 3 plus I over 1 minus 2I? So when there's a binomial denominator, you're still not allowed to have i's in the denominator. What you do is you multiply by what's called the conjugate radical. You take the same 2 terms, but you change the sign in between. Like that. Okay? So bracket, 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 bracket. That helps to make sure that you FOIL correctly. Okay? So go ahead and FOIL. Ooh, here, let's go. That's you, eh? That's your thing. We took it out from January. Yes. Plus 2i squared. Good. All over. Yeah. 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 It's easier to simplify before. You can sub in, actually, the -1 if you want. So sometimes what I'll do is I'll just erase this, so I don't have to recopy everything again. So 3 plus -2 is? 3 plus -2. Good. 6i plus I is? Over. What always happens in the denominator, remember the whole point of doing this was to get rid of the i's in the denominator. This will always cancel out. So you're left with 1 plus 4, which is 5. So the answer is 1/5 plus 7/5 I. Okay? Thank you for coming in. Bye. All right. So what's the point of doing this? Why do we do this? Oh, the point of rationalizing? Yes, this is all rationalizing. Yes, is because we're not allowed to have i's in the denominator. It's kind of like leaving a fraction as 2/4. You can't leave fractions as 2/4. You have to reduce them to 1/2. It's more proper. That's the same thing here. Okay? But why do we start involving complex numbers? Because what happens when you get something like this? X squared plus x plus 1. No, let's go... let's get a little bit interesting. Yeah, let's do that one. So you can't factor it. If I asked you to solve this equation, solve this quadratic equation, you can't factor it because you would find two numbers that multiply to 3 and add to 2. So now you would have to do what? If you cannot factor, how do you solve a quadratic equation? Quadratic formula, which is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So you get okay, this is what? This is what? Good, so 4 minus 12 is? That's okay. Minus 8, all over 2. But now you know, before you would say no solution. But when you see this symbol at the top, that means your answers can have i's. So you say, we change this. So it's -2 plus or minus, what does this break down to? Nope. How do you rewrite and convert that into a complex number? First, always put the... all over 2. -2 plus or minus, what does this work out to be? What's the point of doing this? Yeah, what is the square root of -1? I. Not I squared. I squared is -1. But this is I. This is what? Which is better written out front. Root 2, all over 2. And remember in math, if you have plus or minus signs for fractions, you can't cancel out of just the front 2. It has to come out of everybody. So the final answer on this is -1 plus or minus I root 2. I reduce the 2 out of everybody. It's like writing each one over 2, right? Remember I was showing that? So -2 over 2 is this. 2I root 2 over this. 2I root 2 over 2 is this. You're not trying to bring in I squared. The point of using I squared as -1 is if you have an I squared, you don't want an I squared, and you put in -1. You want I's, not I squares, not I cubes, not I fourths. You always want just I's. But that's the answer. You're not trying to bring in I squared. It's just that the point of complex numbers is how do we give an answer to this without just saying no solution? So we introduce the fact that I is the square root of -1. To be able to say, to be able to actually take the square root of -8, you have to include I's. Where? What 2? Here? Okay, so this is just simplifying from here to here, right? Because isn't this really this? So this and this reduces to this. This and this reduce to this. Okay. So that's complex numbers. Okay? All right. Sure. It's all on video, but